So hey guys, I'm Vincent from PHI Society, and this is going to be Josh Hortaleza's Data Science, the Approach, the Skills in the Job Market webinar by PHI. Let's get started.
Sure. So thank you very much, Vincent. Hello, my name is Josh Hortaleza. I am a third-year computer science major at Wilfrid Laurier University. Happy today to talk about data science. And I guess a little bit of background on myself and what this is covering. This is going to be covering my path in data science and just general advice for people who are actually going to be in data science. I understand that at Laurier, data science is a very young community. It's a very young study. And with the creation of this new major of data science, I'm very confident that this cohort, as well as future cohorts going forward, can hopefully pursue this very exciting career. So my background, my name is Rationale once again. I'm a third year. I've worked 3 internships. One of them was at Intact Lab. I was a deep learning intern. The second one before that was at CIBC Data Studio. I was a data science intern. And the one before that, I was at GMG Consulting, and I was a proprietary trader. Harvard Business Review called data science the sexiest job of the 21st century, and they did that in 2012. It is now 2020, and is that true? This is something that, when I read this article, I was very shocked to hear that, because wow, I was like, well, this is very cool. This is a growing field. Everything cool is based off data science now. This seems to be a very trendy, very hip industry to get into, and so much so that there's a whole degree based on it now. So hopefully today we can explore whether or not this still remains true today. So what is data science? There are 2 important takes, in my opinion, on what data science actually is. One of them is, is given to me by Wikipedia. That is, data science is the interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. So this is a very traditional definition of what data science is. And then there's one given by YouTuber Jonathan Ma, where he says, data science is about using data to create as much impact as possible for your company. As a data scientist, your job is to solve real company problems using data. What kind of tools you use, we don't care. And this, to me, as someone who's worked for in the industry as a data scientist for around 8 months, holds very, very much true. Using data to make change for your company in a positive way, using these novel methods that no one has ever done before. We know what data science is, but what is data? So data is individual units of information, the singular being datum, and data is everywhere. Data is within sports, data is within classrooms, data is within food industry. Data is all over the place. And the goal of a data scientist is to extract some sort of meaning from that data to make intelligent insights going forward. The actual curation, organization, analysis, and interpretation of this data is called statistics. Data science is very interdisciplinary. It comprises statistics as well as stuff like machine learning, stuff like business, and stuff like computer science. So it's definitely more interdisciplinary in scope. Some data. All right, so what we have here is a positive correlation of a bunch of data points that have been put onto this graph. It has height on the x-axis and weight on the y-axis. And so what this is showing is after you plot all this data together, there's a positive correlation. Essentially what this means is that for the taller you are generally, the heavier you will weigh. And this is an example of some data that has now been giving a meaning when combined together through the use of a line of best fit line, as well as a visualization. Sorry, excuse me. Okay, so now we know what data science is. We know what data is. Now to talk about data science in the actual industry. So data science in industry is very peculiar because it's a very young field. It's a very young industry to actually be part of. Data science, specifically deep learning, has only truly come to the forefront of the industry in 2012, and that was after something called ImageNet came out. And once that happened, once we realized that, oh, like this academic field can really explode in the industry, a lot of people started adopting these new novel techniques, and now it's become a mainstay, basically. So there are three very important pillars when it comes to data science. Number one is programming. So that's like Python programming and like building scripts and whatnot. Number two is research. And number three is business. So we'll be going over these three core concepts of data science. First things first, programming. So the predominant language in the data science industry is Python. We all learned this in CP 104. It should be known to all of us by now. And the reason why Python is used is because all of the main libraries in Python are, all the main libraries that are used in machine learning are done in Python. For example, Pandas is a Python library. NumPy, Matplotlib, all these things are all Python like based. Excuse me. So we do this Python thing in order to do stuff like data processing, to make data pipelines, to transform our data, to extract it, to clean it. Essentially, we use this to make our lives easier when it comes to actually processing raw data. And it also helps us connect to stuff like TensorFlow, PyTorch, and Keras. And these things are libraries that help us actually implement deep learning algorithms very, very fast. Another good part of Python is it also helps us create visualizations like PowerPoints and like graphs and whatnot. It allows us the ability to do that. Research is pretty important. So research bridges the gap between academia, where all the novel fields in data science are created, and industry tools that actually and brings it to industry where actual problems are being solved. So data scientists continually want to improve their models, so much so that they'll hire PhDs in order to develop novel techniques in which to actually like do the actual research. So what do I mean by research? So I mean like papers in academia that people come up with. The industry will interpret those papers and will use them to actually solve their problems. The industry prefers people, when you look at a job description for a research role or a data science role, it is very common for them to ask for a master's degree. And it is for this reason, because you need to be able to understand a paper and you need to be able to like actually apply it in the actual workplace. So an example, here's some like paradigms of research. Academic research is kind of like, okay, is once again, data scientists call upon academia to help solve the problems. And then once they do this through stuff like through paneling, through panels or academic workshops and whatnot, they'll bring it back to their own company for them to interpret and actually use to solve problems and improve their models. And when they improve their models, that's stuff like increasing accuracy, increasing metrics like F1 score, increasing metrics like all of these metrics that define success for them. They will use the industry to improve them. This is important for like a lot of reasons. For example, let's say, for example, that you are doing cancer detection using machine learning. Let's say, for example, your model says to a patient that, oh, you have cancer when you don't actually have cancer. This error is very bad for the person who's using the model, because they have the impression they have cancer now, but they don't actually. So they'll take treatment methods that don't really help them or could make them worse. So an error is, in some types of use case models, is very, very important to avoid, and they have to be as accurate as possible. And research helps them with that. Okay, pillar 3 is business. In my opinion, the most important part of being a data scientist. And what I mean by business is this. So when you're in the industry, when you're an actual business, when you're actually trying to benefit a business, understanding what your business does and where data can help is very important. And I split that into 3 different things: understanding a use case, interacting with non-technical stakeholders, and evaluating aspects of the business where data science can benefit. So what I mean by use case is like, I'll get into that in the next example. Number 2, interacting with non-technical stakeholders. So what that means is people who you work with are not necessarily going to be very technical. How do I distill this knowledge that comes from highfalutin ivory tower academia in order for people who have other backgrounds to interpret that and actually make impact for my company. Because if you can't explain to them how this, for example, black box algorithm can help their company, you will cause no impact, and that wouldn't be good for you or your company. So a third thing is the evaluating aspects of business where data science can benefit. Essentially, that's where that's you trying to be creative and thinking, okay, I have these techniques. These techniques exist in research. Where can we apply the research to make aspects of our business better? So all these things is what I mean when I say business. Here's an example of a business use case. It's called spam detection. So Gmail, for example, uses machine learning to actually detect spam. But the question is, there are things that we have to consider when thinking about the actual nature of spam. Like, what is spam, for example? And the questions maybe you could be answering when trying to solve the problem of spam in let's say an email setting would be, what is spam? What kind of data are we dealing with? How does spam affect our company? What type of model do we need to actually achieve the goal of detecting spam? How do we get the data for it? How do we know what spam is and what spam is not? Like, let's for example, like what happens if something is considered spam but isn't really spam? Then that means that the person wouldn't like have that email anymore, and that email could be very important. That would be an error. How do you reduce that error? And like, how do we know when the model is doing stuff correctly? So these are some of the things that we could like think about when doing a business case. So the next one is, okay, so the data ballpark. Data is a very big industry. It's quite large. So there are things that you can do aside from data science, actually, that encompass the field of computer science and data science. So what are those? That would be data engineer, data analyst, and machine learning scientist. These are a few of the things that you could do other than data scientist. So, for example, a data engineer would use their programming ability, their software ability, to actually create these pipelines where data could be processed and the machine learning algorithms could be applied to it as efficiently as possible. They could also like build pipelines that that incorporate some retrieval from databases and whatnot. Data analysts could find out using data things about the company that can help the company internally. So the difference would be essentially a data analyst would benefit the company internally, and the data scientists could actually build products. That's a distinction between the two. And a machine learning scientist would be more attuned with the research and academia, and could help actually build novel algorithms. So that's kind of the whole point of a machine learning scientist. A PhD is preferred for that, by the way, because research is very, very important for a machine learning scientist to actually do. So they'll spend more time reading papers, if anything, as opposed to like actually coding, even though they may code as well. So the Canadian AI space is a very large one. So as a matter of fact, I heard this from the CEO, former CEO of Google. His name is Eric Schmidt, and he came to Toronto and he told us about like the characteristics of Canadian AI. And he told us that there's actually a phenomenon of reverse brain drain. So these educated people who are educated in Canada used to go to the US, and they used to go there, and they had like a lot of success in the US with stuff like with all those companies that come out of that space, like Google, for example. But now companies are actually, talent is actually coming back from Canada, from the US back to Canada, because there's a lot of opportunity for AI in various cities of Canada. So Toronto is very big for data science, machine learning. Montreal is very big. There's a lot of like academic think tanks there. There's a lot of startups that come out. There's a lot of funding that is being pumped into all of these Canadian cities that are pumping out some very, very strong startup companies. And it's very good to actually like hear about that. We're very happy that this is the case. So the Canadian ecosystem is actually doing very, very well. We hope that happens and continues to push forward in the near future. So that's a bit about the industry. what can you do to actually increase your human capital? How do you get better? 1 minute here. Let me just take a drink of water there. Okay, so how do you actually get better at this? So data science, because of its interdisciplinary nature, there isn't really like a one-size-fits-all class that can make you better as a data scientist. There's the degree that exists at Laurier, and that certainly can help. But in terms of stuff that you can do on your own, here are some things that I think about when getting better as a data scientist. Okay, so we'll bring it back to the 3 pillars. So programming, research, business. Here are some of the things that you can do in order to get better as a data scientist. So programming, having a developer mindset, thinking about where you can find inefficiencies in actual programs, in actual like applications programming. Think like a developer, kind of like lead code is a thing you can do to get better. Understanding Big O, understanding data structures and algorithms are very important things you can do as a programmer. In order to get better at research, that's kind of difficult because an undergraduate isn't necessarily exposed to research. But what you can do is get better at math. You can get better at linear algebra. You can get better at reading actual papers. You can look at how they formed their hypothesis, how they've done their testing. You can look at the actual, under the hood architectures of various popular deep learning models, like a neural network, for example. You can learn how that works, and you can keep up and you can keep up to date with all the current papers that come out in data science. For example, ArcSiv from Princeton, I believe, is something that exists that has these repositories of new and up-to-date research, and you can actually read the papers yourself, and you can form like your own opinions on them, and you can like see how the process is for going into that. So that's an example of how you can enhance your research ability. The business one is very, very interesting. So my background actually was in business. Like data science is not my primary field. It's actually within finance. So like the actual understanding of the business aspect was very, very like easy for me to grasp once I got into it. But for people who don't necessarily have a business background, what I say is, okay, like you should be doing these case competitions. There are a lot of them at Laurier, being primarily like a business school kind of. There's a lot of business case contests you can do. You can understand stuff like use cases. You can understand stuff like project management, product management. You can read like newspapers and understand like where technology as an industry is going, and understand where technology's place in the economy is. You can understand. You can follow consulting companies and see what they're doing to help companies achieve like higher data science goals through something called digital transformation. These are all some of the things that you can do to increase your business acumen, kind of. Okay, so I'm gonna do some exercise here. Does the chat work right now? Is the chat currently working? Is it? I think it is. Well, if it doesn't, that's fine. But like, okay, this is a test. Cool, got it. So think about what this is. So this is a neural network. This is like a very popular machine learning algorithm. It's like nodes representation. It's like it's a very like outlined thing like this, and it comes up with a solution if it comes up with some sort of like answer for you if you put some input through it. That's what that is. This is a excuse me. This is a gradient boosting tree. So this is another form of machine learning. This is a logistic regression curve. It models it tries to model a binary input. So it has like yes on the top and no on the bottom. There's that. This is the filtering for a convolutional neural network. So this is essentially like if you took linear algebra, this would be like a matrix, and then it does matrix multiplication on an existing input and produces a output in the form of that input's dot product. This is a Bayes theorem essentially, and this is for a machine learning algorithm called the naive Bayes algorithm. This is a sigmoid function. This is used for training a neural network. This is a this is a loss function, so called categorical cross entropy loss. And this behemoth right here is part of the calculus that is done in back propagation, which is another way, which is the pass back way of training a neural network. So interestingly enough, what I've walked you through here is essentially saying that machine learning has quite a bit of math in it. And in order to get better at machine learning, it is very important to be good at math. And the reason why that is because mathematics is how these ideas are communicated. When I was working in the industry, of course they're not going to ask you to solve the derivative of a trigonometric function or something. It's going to be like reading what these papers are saying and what the actual mathematics means, because like mathematics in industry is used to actually describe some concept. The concept could be explained to you entirely in words, but the math is there because it makes it easier to actually disseminate the information, because it's the common language of the industry. Neural networks are math. All the machine learning algorithms are math based. It's very cool to like look at a self-driving car and to look at what it does through what it does, because it's remarkable to actually see a self-driving car. But all of that is powered by math, and to go into machine learning and not understanding math, university level math, would be a disservice to the actual study itself. So by math, I mean like fundamentals of calculus, linear algebra, statistics. It's definitely things that you find in an undergraduate mathematics classroom, in an undergraduate computer science like course. So you'll definitely have your fill of math during your process as both a computer science student and as a data science student. So you'll get your math there. But it's very important to understand these things like in themselves. All right. So side projects in software development and data science are very similar. You try your best to solve a problem that exists that you have trouble with. If you were in software development, maybe you can make an app that is a ruler, or make some sort of website that displays your achievements, that is responsive, and that that is dynamic. You can do that as a software development one. But for data science, a lot of them actually use data. So of course they use data. So that would be stuff like interpreting data, analyzing it, cleaning it, and then applying a machine learning model to it and solving a problem yourself. So that's and the idea of a side project is to show the industry that you are actually interested in what you are studying and you're willing to do it on your own time. And this is quite often a big differentiator when it comes to people who look at resumes who are trying to decide who to hire. This side projects thing is also a very good thing to do when you do not have like a job out like from the get-go. So that'd be when you're in first year, second year, maybe you're not in co-op yet. These are some things that you can do when you don't have experience, and they'll teach you a lot too, because these are very applied things that you can do. Some examples of side projects are stuff like I have a list here of 6 pretty good projects, and I think anyone in this webinar can do them. So that would be like artificially created face generation with GANs, or hate speech detection with a naive Bayes classifier. So these are all the type of things that you can do as a side project, kind of, and these will definitely boost up your resume quite a bit. So if you can actually do a side project, go and make your own machine learning end-to-end pipeline, apply some machine learning algorithm to your data, and come up with some sort of answer to the problem that you had in the beginning, that is huge to talk to in an interview. That's huge. So very important to do that. Okay, so GPUs and hardware. The thing about GPUs is that a lot of the actual machine learning research is done with GPUs. Reason why that is because they're very good at doing matrix multiplication, which is a big part of data science, multiplying matrices. So they do that very well. So all the current training that is in industry is done on GPUs. So that would be like an NVIDIA card or some card like that. Having one would really boost up your learning, because it would the actual models that come in would actually work on your computer now. You wouldn't have to like outsource something to a cloud company. On the topic of cloud companies, there are things that you can do, like Google Colab for a GPU, or AWS, and it's pretty important to actually do your training of the model on a GPU, because it's much faster that way. And this is how industry does it. Working with GPUs is actually very important if you're in data science, because everyone, like, this is a standard. It's a standard to actually go and train all your models on GPUs. The CPU doesn't cut it. So for those who can't necessarily afford a NVIDIA Titan 2080 graphics card, you're more than welcome to do your training on a cloud service. Okay, so now we know what it takes to raise human capital. We know what data science is. How do we take those skills and translate them into an actual job? So first things first, to ask the question, what is an internship? Like, what are we actually doing when we're going to co-op and applying for jobs? What are we doing when we interview? What are we doing when we actually get the job and we're now an employee for 4 months? Here's an answer to that question. So both employees and employers like internships. Like, for example, if you're an employee, it's a chance to gain valuable skills and experience in the industry that you want to be in. It's a chance for you to pivot into a career that you want to be in. It's a chance to learn about different company cultures, and it could be a potential means to a full-time offer down the road, because essentially a internship or a co-op is a 4-month interview. So it truly is a way for them, for you to like understand them, and it's truly a way for them to understand you. If you're an employer, it's good to have this temporary labor that you don't necessarily have to give health benefits to. It's a way to establish a talent pipeline to make hiring easier down the line. And once again, it's kind of like a 4-month interview stage process in order to see how interns integrate into the company and whether or not they want to give you a full-time offer down the line. Okay, so what do employers look for in a candidate? So the thing is, when I was starting in data science, I didn't have any experiences. I had barely, I had maybe one project, and I worked for like, I had like 2 internships that were not directly related to data science, but I tried my best to like use them both in tandem to try to position myself to get a job in data science down the line. So a company kind of looks for 2 things when looking for a intern, whether it be in data science or otherwise. They look for what's called a finished product, where you're generally in your 3rd or 4th year, you have a few co-ops under your belt. You can bring your knowledge from those past co-ops and become a functioning value add immediately to the company that you'll be interning at. Or you can be a ambitious project. You can be someone who maybe in their 1st or 2nd year not necessarily know everything, or maybe know what like a GitHub is, or know how to like go through a workflow properly, but you can work hard and you can learn fast. And you have like maybe like a year's worth of like CS background, which could help you down like in that job. So they can train you in their way. So like, even though you don't have any experience or are a fresh grad from high school, it is completely okay for you to be like that, because companies also look for you too. Companies are willing to invest on your potential, and they're willing to reward you for actually benefiting them. So it's from any standpoint, whether you're a finished product or an ambitious project, a company still wants to hire you. All right. So the need for data scientists. So data scientists exist in every industry there is. They're in journalism, they're in banking, they're in insurance, they're in technology, they're in everything. Even real estate, yeah, like finance as well. So, however, not all data scientists are treated the same way. For example, if you're at Google, or if you're at DeepMind, or if you're at a company that truly needs data as their primary driver of their core business, a data scientist is considered an essential employee. and you'll definitely be like treated differently at a company where you're the primary driver of the business than if you're at a company that treats you as a luxury or a competitive advantage as opposed to like being a part of the core business. For example, a bank's core business is like probably in the retail banking space. They make a lot of money through like loans and whatnot. They make a lot of money through like M&A activity and like deal activity and whatnot, not necessarily through actually putting data science products out there. So when I was at CIBC, I wasn't necessarily like the main product over there. So I wasn't necessarily like treated like amazingly, like out of this world amazingly, like for that you might have been that you might see in stuff like Google or Apple's like employees get treated well. So CIBC at CIBC, data science wasn't necessarily like a big more importance. They were there because all the other banks got data scientists, therefore they should have gotten some too. So there's that. And but however, at Intact, machine learning actually comprises their new model of valuating someone's risk. So now a data scientist is actually very, very important to a company like Intact because insurance's core business is pricing risk. And doing it more intelligently through machine learning, Intact really needed data scientists to work for them. So they were treated a lot better than if they were at maybe like a real estate company. So finding where data scientists fit within the company and where you and your skills will fit in the company is very, very important. Okay, so actually searching for the job. There are 3 things that I would recommend when it comes to channels when searching for a job. Number 1 is networking, number 2 is job boards, and number 3 is hackathons and job fairs. So networking. I would imagine that networking is heavily covered by the co-op office, so I hope to not overlap with what they say. Networking is actually very, very like important in computer science fields, tech fields, in data science especially, because contrary to popular belief, people like do communicate, people do talk, people do want to get to know you, and it allows them to get like a hold of what you're actually about. So and for you, it's important because you get to learn about the company before going in. You get to learn a lot about the actual industry. You get to learn a lot about what actually differentiates a academic data scientist versus a industry data scientist, or maybe a data scientist in a bank or a data scientist in an insurance company. You can definitely like use these networking tools like LinkedIn, for example, to actually like learn much more about your industry. And I have some sample questions to ask as well on this slide. The biggest takeaway, in my opinion, from actual networking is I believe that you should be very, very focused on obtaining a mentor. A mentor will help you with your resume, will help you with your job applications, will help you learn about the industry. And this is someone that maybe you can talk to a lot, like maybe on the regular, that can give you some guidance in your field. And the mentors that I've had have definitely helped me a lot when looking for a job. I would pass them my resume. I would ask them how the resume was. I would ask them what I could change. I could ask them how to look for a job. A lot of the info in this talk actually comes from my mentors and what they said to me. So actually, like learning through other people is a huge way to explode your growth as a data scientist. But it's all about actually forming that positive relationship with them over the course of like a long period of time. You don't necessarily ask for a job right away. Okay, so job boards. Job boards are interesting. You have a job board on Co-op Navigator, and job boards in real life are much the same. So maybe you just go on LinkedIn and you go look at data science intern. You do a search for that. You do a search for intern or summer 2020, all these things, and companies will post to job boards in order to attract candidates. Is this the most ideal way to get a job? Probably not. However, like I got my jobs at CIBC and at Intact through a job board, so it can definitely be done. But like as the co-op office has told me, a lot of jobs are actually filled before they reach the job board. So ideally, you should be looking around like deeper than purely a job board, but it can definitely be done. This is actually the posting that you see here is actually the job posting that got me the job at Intact. Not this one per se, but like the one for fall 2019. So I do owe a lot of my career success to a job board. So job fairs and hackathons. Hackathons should be well known by all of you at this point. The past talk from PHI was by the Golden Hack, which was a very great talk by them. So all of you should be well acquainted with the idea of a hackathon. Please go. Like, hackathons are great. They're free, first of all. Second of all, they have all of these industry partners in this one space, in this one area, and they're there for you to talk to. I have like a funny story where I was at the Deloitte booth. I was at Hack the North, and I was walking around at the booths, and Google was there, Shopify was there, and I see Deloitte, and Deloitte is a very good company in the tech consulting space. And I looked at their merch on their desk. Companies will like give merch sometimes that has like their company logo on it. And I said, hey, can I have this water bottle on your desk? And then they said, yes, you can have this bottle. And I took it. And then I said, okay, thank you. Can I have a job? And then they said, yes. And they said, okay, we'll interview you. So they brought me into the room to actually interview with Deloitte, like right away from this tiny, minute conversation. They actually did interview me for Deloitte, and that's incredible. And you probably could not find that anywhere else. A hackathon is really valuable for stuff like that, for actually seeing these companies. And another story I have about hackathons is that my replacement at Intact won Hack the Six of last year, and won last year's Hack the Six, and Intact was the primary sponsor. So the guy who won is actually my replacement now at Intact. So by winning a hackathon through they actually like doing a hack is also like big for your job search, very big. The platinum sponsor will definitely like take notice if you actually win a hackathon. So I highly recommend you go. It's a great learning experience, and technology converges there. So recommend that. All right, resume. So this is my resume. I won't touch on about like the styling, but what I will touch on is essentially why I have the things that I have. Like, it's very important to have like numerical like metrics on how well you did, and I bold things that recruiters could look for when searching through a resume. So stuff like FTE savings or 18% or Python Matplotlib. These technologies that I use at work are things that recruiters and HR people want to see. They want to see these. They want to see what impact you made on the business. And if you can demonstrate that through a resume, through your wording, you will definitely have a leg up versus someone who does not. All right, so that's that. I'll talk a little about like internship peculiarities, things that I've seen like working in tech industry for over a year now. Things that I think are pretty like interesting to me, things that I've been thinking about, and one of them are prestige and exit opportunities. So prestige is like when we think of prestige, you think of FANG, right? So Facebook, Amazon, Apple, Netflix, Google. Prestige isn't necessarily important in itself. However, it does lead to things like exit opportunities. So let's say, for example, you get an internship at Google. Getting an internship at Google is great. You learn a lot. There's probably like massive resources there, and you wouldn't be blocked at all while you're working there. But the advantage of working at Google extends outside of the internship, as you might know, because it signals to other employers that, hey, this guy worked at Google, so maybe he'll work well with us. Whether or not that's like the best reasoning in the world is up to you to decide. But there are tangible benefits from working at these big companies, and is it like recommended to do that? Probably, but this idea of prestige and exit opportunities is definitely something that you want to think about, because to be honest, all of these companies, with the exception of maybe Amazon or Google, are very mature products, and they don't have a lot of business differentiation. For example, Apple is only within the phone space, the tablet space, and like this and the software space. It isn't a very mature business. It's already a very mature business. So whether or not you work on things that are cutting edge is something that you have to figure out. And figuring out what you want to do with your like life as a tech person is something that, in my opinion, that you should be thinking about. All right, imposter syndrome, very important. So so I'll give a definition of this. It is the persistent inability to perceive that one's success is deserved or has been legitimately achieved as a result of one's own effort or skills. So what this essentially means is that like you believe that you did not deserve the job that you got. You believe that you're a fraud, a charlatan, and a fake, and you'll be ousted as such, and you'll be exposed as such because you somehow fooled the company, or you somehow believe that that you were given this job through something that other than your skill. Uh, and and this is something that a lot of people experience when they enter into a tech field, because truly speaking, to be brutally honest, who knows about neural networks? Who knows about who discovers these things in their daily life? It's something they have to like search out for. And there are probably a lot of candidates that were denied for you to get in there. So first of all, I have some things to say about this. Number one, it's kind of weird to think about this imposter syndrome, because if you truly believed that you didn't deserve it, you can't just give the job to someone who did deserve it. In that is your opinion. You wouldn't necessarily do that. And if you're not going to do that, then it's really weird to think about that. So so that's interesting. Second of all, interns don't have an idea of what the company needs from them. So your idea of what is satisfactory and what the company believes is satisfactory is could be like totally different. Therefore, you could feel bad according to your standard, but a company could be perfectly fine with you. The third thing is that it's the responsibility of the employer to determine truly who is worthy. If you somehow fooled their system, of hiring, it's their fault. They should have had a more robust system. Not to say that you'll totally fail, but like if, for example, you did, it would be not a fault of your own, but a fault of the actual company. So keep in mind when you actually go into industry, if you do get an offer as a data scientist, you probably deserved it. You definitely did, because you went through their process, you went through all their reference checks, you did all these things that they asked of you, and they picked you in the end. So don't worry at all about whether or not you're qualified, because you probably are. Last thing, free food, open offices, and other traps. So a thing to note is that tech is a very trendy space. It's a very like, oh, we'll have slides in our office. We'll have like free food. We'll have this like cool, hip, open office space. These are good things, sure, but like there's a secret intention behind them. The intention is to keep you in the office for longer, number one, and to save money on rent, number two. So the actual amenities like a gym and whatnot, it's designed to actually keep you in the office. It's designed to make you reliant on the actual business itself for things that the business should not be responsible for, like cooking and like working out and stuff, which are things that you should do on your own time. And excuse me. And so yeah, these are the things that you should look out for, because you shouldn't work at a company entirely because they have like a foosball table or like a pool table or like unlimited vacation. Unlimited vacation is also a thing that people offer. These companies offer. Realistically, you're not gonna have unlimited vacation. You're gonna have like 3 weeks or 4 weeks, and these perks are designed to keep you there in the office and to retain you and to save rent. Like in open office space, you can fit so many more people, employees, in an open office than in a cubicled standard office space. So be wary of these things and keep these things into consideration when looking for a job. That's my talk. Thank you very much for listening. Thank you very much to Phi for having me. And I'm willing to take any questions that any of you have. Thank you. Any questions? I'm more than happy to take them.
Hey Josh, it's Ian here from Co-op. Thanks again so much for coming tonight and for participating and for sharing your expertise and insights with the entire group. There aren't any questions in the chat quite yet. We'll open that up for just another minute or two if that's okay with you.
Sure, absolutely.
Okay.
We're happy to answer anything.
All right, so if anybody did have a question they want to throw in the questions pane or the chat pane, you can go ahead and do that now. And maybe we'll give that one more minute as people maybe roll in a question or two. The other thing I wanted to mention in speaking with Josh and just in preparing a little bit for this presentation is just how big of an impact Josh had in the development and creation of the data sciences program. And it's really wonderful to have Josh coming back like this after all his work in Senate and getting things set up. To share expertise like this and to share some best practices, because certainly it can seem challenging when you're first starting out in any type of job, let alone a relatively new program, about things that you need to be thinking about moving forward and some considerations going into the early parts of your career. So really can't thank you enough, Josh, for spending this time with all the students that participated tonight and for all those insights and such a wide range of information. It was really wonderful.
Well, thank you for having me. I do appreciate like you taking the time to actually like have me here, and I'm very happy to speak about these topics because this is a field I love very, very much and I hold near and dear to my heart. So thank you again.
Wonderful. Okay, so we'll give a last call for questions. We haven't had anybody put anything in the chat quite yet. Maybe I'll just ask one. If we don't get any after that, we'll look at shutting down and we'll call it for the night.
Sure.
Josh, one of the curiosities that I have, oh, we got one in the cloud. I'd rather go with the student's question than my own. So let's see what this is.
Sure, absolutely.
So the question is, what obstacles did you come across when seeking your first internship, and how did you overcome them? That's from Joseph. Thanks, Joseph.
Good question. Thank you. So obstacles were so like actually like finding where people were hiring at, and was a big one. The actually like to be like honest here, a lack of guidance was very, very like detrimental for me getting a job in the first place. I didn't know that I actually could be a data scientist. So essentially, like when I was in like the first year of a CS program, I thought like all I could be was a developer. I thought like that data science was completely out of my reach and out of my my frame for what I could do. So I didn't necessarily entertain that as a career. I actually kind of fell into data science like by accident through my time with CIBC. I actually interviewed for them as a developer, but got a job as a data scientist when I showed them my project for data science. So kind of like the lack of guidance from that I had, which is like very much my fault, as well as like not knowing like who was hiring for data science, were things that like impeded me in my career. And I guess how I fixed that was through the networking thing. I saw once I actually like started to interview for these fields. Once I started to actually go about and learn more about data science and learn more about all these things, is when I actually decided to get my own mentors and get people who could actually guide me to doing well in this field, and actually understanding the businesses of where a data science person would be needed, understanding the job channels were the things that got me out of these obstacles. So hopefully that answers your question.
That's great. Well, thank you for that. And the second question is, how do you balance networking in your first placements with any other obligations? So whether it was schoolwork or your actual being at work, having side projects and things like that, how did you balance networking with the placement?
Okay, so good question. So I networked a lot. If you asked anyone at my company, at all the companies that I worked at, about like, oh, how did I manage networking? Like they'll tell you that I networked like every day, every single day I networked. Like I told my bosses explicitly that I would be networking throughout my time like at the company. Intact actually was very like nice in helping me network, because I said, hey, I want to talk to someone who some people who are actually based in the Montreal office. So they flew me out to Montreal, and they actually got me like a seat at the table with these very big executives to actually learn from them. So companies are very supportive of you networking. Like at CIBC, like maybe like outside the company, like what I would do is like I would have my obligations, and then I would schedule these calls outside of work hours or at the lunch of my work hours, which coincide with the lunches of anyone in your time zone. If your lunch is at like at 12 o'clock or 1 o'clock, the good thing about technology is that like your lunch can be whenever you want. So from like 11, you can have lunch at 11 or lunch at 1, as long as you get your work done. You can fit in a call with. I had like many calls with people from outside of CIBC, outside of Intact, while I was working there. Like make it a focus for sure, but like obviously you shouldn't let it impede like your actual work, because like your duty is to work, right? Networking is all like stuff that you do to help your career outside. So like how you balance it really, just you find the time to do it if you actually like talk to people who you want to get to know. So that's how you kind of balance it. Like it's either through the cooperation of yourself and the company, or you finding time through lunch or outside of work. And people are more than happy to fit within your schedule.
That's great. Thanks for that question, Thomas. That's great. We're at the end of the questions once again. If there's anything someone wanted to throw in, the one comment I would make about networking too, especially when you're on your placement, is that you're going to get exposure to so many people, not just in your organization, but outside of it. And sometimes it's great to be mindful of the connections that you're making with people who aren't within your organization, but who you're developing really positive rapport with, whether it's working on projects together or maybe you're helping a certain client. Just being mindful of the rapport that you're keeping and being as polite and courteous as you can may leave you open for opportunities later when you are nearing the end of your work term to send a follow-up. Hey, I'm ending my work term shortly. I just want to say what a pleasure it was, working with you on these projects. Hopefully our paths get to intersect again in the future. And even just that act of consciously thinking about somebody in a positive way and then saying that to them, it doesn't even have to be long. When you do go back into that workplace or into the job search networking kind of mode, you now have someone that you had pre-set up this positive relationship with, and that you had thought about them when you didn't need anything, and then you can reach back out again and talk about more, which is really nice. There's one more question we had in from Thomas. You mentioned not to start out networking by asking for a job outright. So how would you initiate a conversation with someone, like in a coffee chat, like a coffee or meeting outside of an interview environment? Would something like asking what they're working on currently, would that be a good conversation starter? Or how would you go about this is what I want to talk about with you?
Very good question, actually. That's because like, yeah, you shouldn't really start off like asking for a job. So like what you should be doing is trying your best to like learn more about what they actually do. So people are more than happy to talk about what they're passionate about with anyone who's willing to talk to them. So first things first that you would do is you would say, hey, my name is Thomas, and I'm a student at Wilfrid Laurier University who wants a career in data science. I'd love to talk to you about your time and experiences and your path getting there. Because what I noticed among talking to like everyone in the industry is that people like talking about themselves like a lot, and people are more than happy to tell you their story over a coffee that they'll probably pay for. So obviously we wouldn't expect that, but like that's definitely my experience. But so stuff that I would ask them, for example, is stuff like that kind of like that kind of like digs start questions that kind of like dig into what they're about, and then really being an active listener throughout the process of the actual coffee chat or the actual conversation. So for example, like if they say, oh, like I did, you ask them, oh, where they went to school, and they say, oh, I went to school at Wilfrid Laurier University, where I took like my classes there, and then you would have to ask them further and further and further about that. Networking is a lot about like your conversational ability. The ability to be an active listener is, in my opinion, the most important thing you can do as someone who's talking to someone else, because that shows that you're actually interested in what they have to say, and you're not like defined or like you're not like confined to one script that you have. So stuff like like how is failure dealt with at a company you work at, for example. I have on the slide here. They would expand on that. They would see about that failure, and then you would ask further. If you wanted to know more, you would ask further about that topic that they brought up. You really have to like work with what they give you in their responses. So and in this process, you form a relationship. And once you have that relationship, then you can like use them as a resource going forward as your career grows and blossoms. So that's kind of like what I would say. All these things that I would say that are not, can I please have a job? If that makes sense.
That's wonderful advice. So we are nearing the 1 hour mark. So Josh, what I was wondering is if you wouldn't mind going back to your main title slide, are you okay with people reaching out to you either on LinkedIn or elsewhere if they had questions after the session ends today?
Oh, absolutely. Yeah. Like once again, my name is Josh Hortaleza. I ripped this off on LinkedIn. It doesn't look like that anymore, but like the name is still the same. So yeah, I can I worked at Intact. You can find, I'm at a CIBC Data Studio. Like that was you can contact me through LinkedIn if you have any questions at all. I'm pretty sure they'll give the slides out of this presentation out. So yeah, like more than happy to take any more questions through a personal medium like LinkedIn. More than happy to do that. And I'll put my email like in the chat, I guess, if that's also contact me through email. Yep, there we go. So that's it. That's my email. So yeah, definitely can contact me.
Okay, I'm just going to copy and paste that for everybody there. So if you guys are at the chat pane there, you should be able to see this in just a second. Josh, I am having an issue just copy and paste it. Can you do the exact same thing, but change the to from organizers and panelists only to all?
Oh, okay.
Understood. Oh, actually, someone's saying that the chat might be blocked. Is there a chance you could put it as a bullet point underneath the other items in your presentation really quick?
Yeah, sure. I can do that. If I can find a way to do that here. If I can edit.
Oh, are you in PDF right now?
I am, yeah.
Okay, are you okay if I just read it off for people so that they can document it?
Yeah, absolutely, yeah. Go ahead.
Okay, folks, it's HORT 0660 at mylaurier.ca. So HORT 0660. Oh, I think I just got it. Let's try that. Yeah, there, everyone should see it in the main chat now because that's to everybody.
All right, cool.
All right, so we'll wrap things up. Thanks again, Josh, so much for participating tonight and sharing your wisdom. And we'll bid everyone a good night.
Yep, absolutely. Stay safe.